So, hi everyone, and welcome to this actually 22nd Urban AI conversation. My name is Hubert. I'm the founder of Urban AI. Urban AI is a global organization dedicated to the emerging field of urban artificial intelligence. We federate a think tank with which we are doing research and experiments on this field of urban AI. Also, a consulting branch with which we help urban organizations, we assist them in their urban AI strategy, policies, or projects, and a community to which Ariel is actually part, a community composed of 200 worldwide experts, entrepreneurs, researchers, public servants, with who we explore, collaborate, work on urban AI. And I have to say that this Urban AI conversation is a bit special because we're organizing it as part of the Urban AI Academy. So we announced the launch of this program now a few weeks ago, really with this idea of democratizing, making accessible urban AI knowledge, urban AI skills to help organizations and individuals from all around the world, no matter the regions, no matter the size, no matter the capacities, to attend this program and to benefit from it and to use AI for more sustainable cities. I will actually let Omer, just before starting the conversation with Ariel, introduce a bit the program. Omer is the program manager of the program AI in Urban Planning. Omer, the floor is all yours.
Awesome, thank you. I'm going to start sharing my screen. Hubert, please let me know if you can see the screen now.
Yes, perfectly.
Yes. Okay, here's slideshow. Okay, awesome. Hi, everyone. Welcome. Good morning, good afternoon, good evening, wherever you're joining from. My name's Omer. I'm the Urban AI Program Manager, and I'll be on your side as you join the program with us. So the program is called AI in Urban Planning. The program is designed as a professional program, allowing people to explore, understand, and master the transformative impact of AI in urban planning. This is a fantastic program for anyone who is coming in and wants to grow in at the intersection of AI and urban planning. So urban planning firms, municipalities, architects, city leaders, as well as students. They're welcome to join this program as well. Transportation authorities and real estate developers. The program is 6 weeks long. I'll show you what that looks like as well. And it starts on March 11th with our orientation module. The program is led by 6 world-class instructors. One of them is joining us in the conversation today. But we have Laura, Ariel, Damiano, Carla, Federico, and Ariana, all of them coming from 6 fantastic organizations. They have diverse experiences as well. And each of them will be teaching one of the modules. And they will all these 6 modules will allow you to understand AI and urban planning from different perspectives. The program looks like this. The orientation module starts on March 11th, and then we have the first module will be about defining urban AI, and that will lay the foundation for rest of the modules as well. Second module is urban AI for insights, transformation, prediction, and consensus. That will be taught by Ariel. Then we have module 3 about generative AI for participatory planning, then generative design for scenario planning, and then regulatory planning. And the last one will be about urban project monitoring. A lot of all the modules have been described on our website as well. And at the end, if you have any questions, please put them in the chat. We can explain those to you as well. For each of them, the participants will also receive an expert toolkit, which is co-authored by the instructors. And that would really give you a lot of foundational knowledge, but it will be filled with resources and next steps for your urban AI growth as well. Along with the live modules and the expert toolkits, you will also be integrated into the Urban AI ecosystem, and you'll also have access to the Knowledge Hub, something that Urban AI has been building over the past 5 years through our fantastic networks, through our events, as well as our research activities. During the program, you will also have opportunities to be part of networking sessions. These are not mandatory ones, these are optional, but you'll have a chance to be part of them and connect with other people in the field. This sort of summarizes my presentation that it is an elite professional program by world-class instructors. You will also be integrated into the Urban AI ecosystem, and you will gain exclusive access to Urban AI resources, tools, and insights. Just to finish off the presentation, there are three ways that you can be part of this program. So there is the essentials package, there is practitioners package, and teams package. We have a fantastic table on our website that describes all three of them. And in each of them, there are different benefits that are provided to you. And practitioners and teams, it's the key difference is that with teams, package, practitioners can come in as a team, either be part of their organization or different organizations, but they can come together to be part of, to come together to join this program. A gentle reminder to everyone that the program starts on March 11th, and the deadline to sign up is this Friday, February 28th. Thank you very much.
Thanks a lot. Many thanks, Omer, for all those elements. So if you have any questions, any inquiries, feel to directly reach out to Omer. To jump on the hard topic of this urban AI conversation dedicated to AI agents and urban planning, we have the great pleasure of welcoming today Ariel Noyman. So Ariel Noyman is a research scientist at the MIT Media Lab, also lecturer at Northern University, at also the MIT. Ariel opened several city science labs all around the world, including recently in the Negev, in Helsinki, in Shanghai, in Andorre, and lead and conducted several pioneering research. And we will see it today on urban simulations, on tangible interfaces, and also on data-driven and urbanism. So really thanks a lot, Ariel, for being with us today. And regarding the program of this discussion, we'll first have a presentation from Ariel on AI agents and urban planning, then a discussion and conversation, and lastly, a Q&A session with all of you. So if you have reaction, questions, remarks, feel free to use the chat, and we will ask them directly at the end to Ariel. Ariel, the floor is now all yours for your presentation.
Thank you, Hubert. Thank you, Omer, for the introduction and for setting up this lovely intro to the program that we are currently designing. I can assure you this is a fascinating program, and I'm myself going to attend all the other sessions as they are, I think, fulfilling and interesting in this emerging field of urban science, urban AI. Let me hear if you can see my screen. Okay, awesome. So we can kickstart. So again, Hubert, thank you very much for organizing it and for the opportunity to share some recent work on the analysis and simulation of human behavior in cities. So as Hubert mentioned, I'm coming to you from the MIT Media Lab, where together with my colleagues, we've been developing a whole slew of tools and platforms and systems to work on that intersection of the built environment and technology. And I think many in this call for sure know that to a large extent, cities are often thought about and also designed and planned from above, from the left side of this video, with limited understanding of what the user need, experience, feel, or want in their built environment. And that question of designing cities, of urban planning from the user perspective, intrigued urban thinkers for more than half a century. Notably, in the 1960s, Jane Jacobs and later Kevin Lynch discussed the idea of designing and planning cities from the point of view of the pedestrian. Now, Kevin Lynch, who was an MIT professor for urban planning, also described this idea as city imageability, which is his way to define and observe different elements of the city as instruments and tools for wayfinding, navigation, orientation, or even safety and security. In a later work, 1964, Kevin Lynch created what is known as the view from the road, in which he basically mounted a camera, a dash cam, to his car and traveled all across the city of Boston in the 1960s to communicate what he called the sensation of traversing through the built environment. But the problem is that in order to test imageability for non-existing environment, for future environments, for places we are currently developing and planning, we need to be as wealthy as the design team of the Lincoln Center in 1959. They can afford to build a human scale model in which you can stand in the middle and experience the environment that is about to be planned. But in most cases, we don't have these luxury. And so over the past 6 decades, we harnessed the rigidness and accuracy of computational systems to imagine cities before they're being built. The first computer graphics in history from 1961 was actually depicting driving through a planned highway in Sweden. In the 1980s, the Berkeley Environmental Simulation Laboratory built extremely highly detailed urban models and rendered the experience of traveling through different weather conditions in San Francisco and LA and some other places. In the late 1990s, at MIT, Eran Ben Joseph and Hiroshi Ishii developed what is known as the Luminous Planning Table for an iterative city planning platform. And if you note that the diagram on the bottom right side, you can see a streetscape camera simulating the pedestrian view. What stands in common to all of these tools, platforms, and systems is that they acknowledge that early stage city planning usually include very crude representation of the city, which makes it very difficult for both professionals and the public to envision how the city might look like and feel. Now, today, we have different ways of visualizing, analyzing, and communicating what will be the experience of moving through planned cities. One very common way of analyzing the behavior of people in yet to be planned environment is using agent-based models or ABMs. In this work, for example, we used agent-based models to analyze the impact of new master plan to the Champs-Élysées Boulevard in Paris on mobility habits, commerce, emissions, tourism, and more. In 2019, which now I would describe as an ancient AI project, we combined tangible user interface with deep learning GAN model, generative adversarial network model, to visualize the future streetscape environment in an unplanned cities. This real-time simulation generates an evolving image of the city, again, if we take a page from Kevin Lynch's work, and allow the users to understand in real time what is the impact of their planning. And so we saw very quickly that we can use agent simulations to test movement in cities, and we can also use generative models to evaluate the experience of moving through these built environments. But the question is, how can we bring these two together? Or in other words, what if we could interview and discuss with our agents while they move through our simulated city? And so this was the motivation for the work that I'll present here today, in which I'll share current research on the topic of simulating urban behavior and experience using generative AI. The main motivation for this work stems from what is now a seminal paper in AI, which is known as generative agents. Generative agents are basically computational entities that simulate human-like behavior in interactive environments using large language models or LLMs. In practice, these agents can autonomously engage in activities and social interaction, demonstrating what is known as emergent behavior. For example, as you can see here, Isabella Rodriguez is deciding as an LLM to organize a Valentine's Day party. Now, nothing in her instruction tells her how to communicate that party to the rest of the network. But as you can see, some people decide to invite their own friends. Some people decide to stop the conversation at their point, and others might even contribute their support and help to organizing this event. This did not exist in traditional agent-based simulation. And so in general terms, when we think about traditional ABMs versus LLM agents, ABM rely on precise rule-based logic, while ABMs rely on rule-based logic, while LLMs can offer flexible decision-making with complex text-based environments. Of course, there are downsides to it, and I think, Hubert, we're going to talk about some of these downsides in the Q&A later. And so in that spirit, the first version of Travel Agent was designed within real-world urban environments. Here, the agent is prompted with a profile and then is given a task in real-world environment. Then on each step of the simulation, the agent has to reason to come up with a decision and reasoning and explain why they made that decision. Here we used Google Street View and perform mapless navigation, and that's an important topic. We have no map or shortest path algorithm here to tell the agents how to walk. They make the decisions on their paths. But still, if we look at the results for this experiment, the agent, in this case, a new student at MIT that was tasked to find a place to have lunch outside, walks around the neighborhood, look for a place that makes sense in terms of having lunch in a shaded area with a bench, and then in each step of the way, explains their next decision. Move left, move right, stop, observe, and every other activity. I'm not going to go deep into the technicalities here, but we had to craft basically a way to convert the Google Street View images into textual representation. Today, we don't even need to do that because the models are becoming so fluent and so capable that you can just throw an image into the model and it will interpret it by itself. Again, this started in 2023, and that technology is moving in very, very fast pace. But beyond moving in existing urban places, how can we use this method to explore future scenarios and design environments? And so the current version of Travel Agent provides the LLM agent with a simulated scenario and an environment, as well as the profile. Once again, we give them a profile, and at each step of the simulation, we can investigate what is the agent observation, reasoning, planning, and decision. Now, I just want to pause for a second on the world. Basically, what is this virtual world that we're providing to the agent? This is a very simple three-dimensional model that every architect or designer or even person without a lot of knowledge in 3D can craft. But we use that model as a baseline to create a guided image generation model, what you see in the middle, in order to provide that as the input for the agent movement. So in the middle, this is what the agent sees when they move. And at each step of the way, they get new type of data and other sensory information. We then pack all of this system into a kind of a client-facing and easy-to-use web app that provides an end-to-end experimentation environment. Just a few elements, I'm not going to go deep into that, but on the left side, you can see the chain of thought, basically how the LLM agent is reaching decisions and make plans in their process. And on the right side, you can see all the different inputs that the agent is getting in each step of the way. The image, a small map. The map is, again, it's not a navigation map, but it's a recollection of places that the agent already visited and a few other sensory inputs. This is the platform in action. I'm just going to give you a very quick few examples. This is interior environment where the agent was tasked to meet their professor in a laboratory setting. And this is an exterior environment. And I really like the one on the bottom, which says cross the street safely. And as you can see, the agent is actually crossing the street in diagonal, which is the opposite. But what's interesting in this experiment is that the agent is actually looking left and right before they cross the street. Now, once again, nothing in the instruction was kind of forcing them to do so, but there is an emergence here of sort of human-like, if you will, behavior. Of course, the advantage of simulating and generating in generative environment is that by the change of one word, we can move from one place to another. So changing from summer to winter, from Tokyo to Boston, immediately changes the entire environment, and that allows us to very quickly simulate different environments and then evaluate them in different ways. I'm very quickly, Hubert, I know I'm crossing my time, I'm very quickly just gonna talk a bit about the evaluation and analysis of some of these experiments. I think the most important thing to acknowledge is that the goal here is not to reach the goal, meaning it's okay if the agent fails in their process, because we learn more sometimes from failed experiments versus successful ones. Meaning, if the agent didn't reach the destination, we want to understand why. what happened down the road. This is not a robotic task of accomplishing all of our tasks. It's the opposite. It's meant to say something about the built environment. And so this is very quickly a few of our themed or experiments and how they perform differently. I think what you can notably see is that during the night session, the agent is more sparse and the decision-making is a bit more spread around, meaning the agent had less confidence in the environment and had struggled a bit more about finding their destination. They also failed more than other places. I'm not going to go deep into the kind of the topical analysis, but we of course analyzed all the text that was provided by the agent as responses, and we looked into what the agent thought about most. For example, in our case, the agent was really focusing on the spatial environment, what's around them, and how to navigate better to their destination. And finally, and I think this is the most important analysis piece we provided from this research, is what was the sentiment of the agent? What was the agent thinking and feeling in each step of the way? So on the top, you can see all the successful experiments. These are experiments where the agent reached destination. On the bottom, you see the failed ones. It's very easy to see that in the failed experiments, the agent has many decision points, one after the other, with no gap between them. The gap is actually representing moving forward for a longer piece of distance. That's to say that the agent was stuck in a point, wasn't sure what to do, and was looking left, right, stopping, thinking, but was not capable of making a decision, versus places where it was much less frustrated on the successful experiments. Again, we can go back to this slide later, but I just want to finish with two last points about potential applications and future work. Naturally, this work can be very applicable for the evaluation and design of new environments. This is actually research by colleagues, Michal Gat-Morad, I think, Hubert, you know her, she's part of the network, that was using VR and AR to test different design environments within a new building. They actually had to commission about 150 people and let them use this VR and AR to explore that unbuilt environment. We imagine the travel agents could be in the thousands running through these buildings in different variations, in different demographics, in different profiles, and then testing new environments on the go, of course, in a much cheaper way and a much more streamlined process. Another, I think, low-hanging fruit application here is the assessment of urban safety and security, particularly through street-level perception, which reveals how visual cues influence feeling and safety. This is a research that was using deep learning to analyze street view images to help evaluate risk perception. But once again, they had to use real people and real humans to perform that experiment. We imagine the travel agents could actually perform that themselves. With that, I'll pause. This is a quick video that demonstrates the travel agent platform. You can see the many different experiments all kind of packed together into this array of analysis. And we hope that the next generation of this tool will allow us to actually simulate many more profiles, many more environments and scenarios, and also really focus on some of these applications that I mentioned at the end. And with that, Hubert, I'll stop sharing and thank you once again.
Many thanks. Thanks a lot, really, Ariel, for this fascinating presentation showing some of the potential of AI agents for urban planning. I think we already have some questions in the Q&A part, so feel free indeed to use this part or the chat directly to ask your questions to Ariel, and we will ask them in a few minutes. I will use a bit my role of moderator before to ask you some questions, Ariel, actually. You show really like the potential of this technology, and we did an interview with Carla Ochoa Saldana like a few days ago. So she's also like professor at the University of Florida and also instructor of the program. And in this very interesting interview, we will put it in the chat. She explained that we should really focus on what can't be done by human, let's say, intelligence when we use artificial intelligence, like using this technology to explore new domain, new area that we couldn't do by existing methodologies. So here's my question: with AI agents, in your opinion, what are the new knowledge, urban knowledge, that are revealed or that are made available thanks to this technology?
Yeah, I think it's a good question. I wouldn't call it knowledge necessarily. I would think that what's very promising, at least, I don't know if we already accomplished that promise, but what's very promising with AI agents is that they're capable of performing a lot of complicated tasks that beforehand had to be either very, very meticulously crafted by code or otherwise would be done by humans, suddenly could be done, I think, in a much more open-ended way using those agents, which are basically, what are those agents? They're basically one LLM connected to another LLM connected to many LLMs in a row, which are basically having an internal conversation and performing more complicated tasks. So I think that it's really not about creating more knowledge. To me, it's more about taking tasks that otherwise would have been very complicated, even for a single LLM, even for, ChatGPT 3 from a year and a half ago. And now suddenly you can see those AI agents capable of performing these tasks in a much more complicated way. In our case, in the project that I showed here, we wouldn't be able to allow an LLM agent walk through a three-dimensional sort of physical environment a year and a half ago or a year ago, because that complexity of chain of thought was not yet there, and we weren't really able to allow the agent to ingest different types of sensory data and then perform complicated tasks. So I think that's one thing that we're seeing now with LLM agents, the complexity of tasks that they can perform.
Okay, super interesting. So about automating some repetitive tasks, this is something we see more and more with the use of those technologies. In the sorry, go ahead.
Just it's not about repetitive tasks. It's more about tasks that are not really perfectly chained one to another. Traditionally, repetitive tasks would be chained one to another, and then we could automate that. Today, those tasks could be sort of open-ended, and the next task would happen by itself just because of the structure of the LLM agents. Think about that example I gave from Isabella Rodriguez. This is an example of something that happens by itself almost, with no interventions from the outside, and nobody crafted that process of how you design a Valentine party, but it happens by itself. And this emergence is what's so special about the LLM agents.
But in the meantime, those LLM, those agents, they are in a sense creating kind of image of the city, as you explained also, and with this reference. And we know that creating this mental representation also have some benefit for human beings to better dwell, to better inhabit a urban space. So do you see some risks on overusing those technologies, or more simply, or just using those technology in urban planning?
Well, for sure. I mean, first of all, this is a very new technology. Like any other new technology, it's exciting, it's fascinating to begin with. But I'm thinking about 10 years ago when everybody were excited about the autonomous vehicles, and everybody thought that's going to be the future of mobility. And when you look at one example of an autonomous vehicle driving through the streets, it's really exciting. It's really fascinating to see that. But suddenly you think about scale, and you think about multiplication, and you think about the impact of many of these vehicles running through the city. And you also understand that they're not perfect. They might be better than human driver, but not to the degree of the perfect driver you imagined. And suddenly all those externalities show up. And so I think we're at the beginning of the same era. We're all excited by what LLM and LLM agents and generally generative AI can do for us, and we're all excited to play with ChatGPT, etc. But when it comes to putting them in critical junctions and replacing existing, proven technology with these new emerging technology, I think we have to take a step back and really validate and make sure that these technologies can actually perform as well as they promise. I don't think we're there, and I think we're going to see sort of back and forth before we sort of balance on what it is that we can really do with them.
Okay, so we're still at the kind of collective learning phase, actually, with this technology. And indeed, I think it's really important to definitely to remind it. We have urban planners in the room, researchers also in urban plannings. you also show some potentialities, some capabilities. But let's say very concretely for you, how is AI more broadly, not only AI agent, transforming fundamental functions or even jobs in urban planning?
Well, I think that one key aspect that is interesting for us, for the urban science, urban planning, architecture, design world, is that the built environment is filled with unstructured data. The built environment is really, really messy in a sense. It's hard to measure, it's hard to sense, it's hard to understand. And that's because we have many, many data coming from different directions, a different pace, the different levels of accuracy. It's a complicated set of data creation. Now, along the same lines, what's interesting with these new technologies is that they are very, very good at digesting unstructured data. They know very well how to take, long pieces of text, images, audio, video, and make sense out of them. Something we couldn't really do easily, at least. Again, sometimes even a year and a half or a year ago. And so to me, there is a convergence here between the complicated nature of the city and the ability to have computational systems that can suddenly react to that complexity in a more beneficial way. It's not perfect, but I think, again, we're sort of taking those baby steps towards urban science. And this is, for me, a big leap moving forward as we start to be able to analyze and digest this unstructured data.
So the ability of using this technology to access, make understandable a lot of unstructured data and maybe urban complexity at the end. I maybe have a final question. I'm benefiting a bit from my moderator role, but you shared a few, like recently, quotes where you make a parallel between like a computational current framework and cities. Could you maybe just quickly elaborate on this, because that's a very interesting idea that we are not listening that much. So yeah.
Yeah, it's a bit following up what I just said. We suddenly see computational systems that we inherently accept as inaccurate. And that's a first. We haven't had something like that in the past. So, if you ask a computer what is 2 + 2 and it would say 5, you wouldn't say that's an amazing piece of technology. But suddenly we talk to, LLMs, to AI, GPT, Gemini, whatever it is, and they, I would say, 4 out of 5 times answer an incorrect or semi-correct answer, and we are all very, very excited about it. And I think the reason is because we are starting to see typologies that remind us of them, or the other way around, meaning they feel very humane in their mistakes, in their errors, and in the way they sort of communicate with us. So we're more generous with those types of communication. And for me, as an urbanist, once again, the city is a messy place. The city is not an organized structure. As much as people might try to enforce structure into the city is an emergence. And that emergence is something that we like to embrace and like to take as a whole. And so to me, when I look at the technological moment in which we live, and I look at the urban moment in which we live, I see some sort of a parallel. I wouldn't call it a full convergence between technology and cities, but there is some interesting moment where the accuracy and rigidness of computational systems is suddenly getting kind of more fluid and closer to how cities behave.
Thanks a lot. And I really like you also use the term of humanizing AI. That's definitely a very interesting approach indeed we're having here. So we already have questions in the chat, so time to open the Q&A session. We have a question from Daniela who is asking, how do you say the culture of society is influencing AI, or which parameters should be considered for this? Yeah, crucial questions of social biases here with Daniel.
Right. Yeah, no, absolutely. So I'll talk about that, especially in the context of the work that we showed now. One of the key aspects we wanted to measure is some of these biases built into the LLMs that we're using for the agent simulation. One of the things we saw very quickly was that if you change the age of the profile of the agent, or if you change the gender of the agent, immediately there are changes to the way they act. And more than that says about the built environment in which the agents move, it says, I think, about the way the LLM is trained and designed to think. And so, this problem is not new in any way. AI models always had the problem of data bias. But I think that the more we rely on them for critical decision making, the more we have to make sure that we understand that these biases are built into the data, and then into the training process, and then into the inference and the usage of these models. And so this is something we have to take into consideration. And if the agent, once again, talking about the work that I presented, if the agent says that demographics or that profile would be afraid to walk down the street, it's not necessarily saying something about the street. It says more potentially about how the LLM agent is being developed. So I think we have to raise those flags and be very, very careful when we present these as annihilated truths at the end of a research.
And those biases are the mirror sometimes of the society, or also, so indeed. We have a question.
Mostly mirrors of the data sets we use to train the models, which are usually Reddit and Twitter, and not very, very high quality data sets. And that's part of the problem of how we train models these days.
That's true. That's true. We have a question from Mo Fendi, who is asking, indeed, in the context of urban AI systems, how do we ethically define and govern the autonomy of agents, especially when balancing adaptive decision-making with human oversight? So what safeguards and methodologies are critical for collecting agent-derived data while preserving privacy and avoiding, well, you just said it, algorithmic biases, but also preserving privacy.
Yeah, so I think it goes back always to keeping a man in the loop. There is no, I don't think there is a substitute to that. We have to make sure that even if we use the agent as a decision support system, we don't use them as decision system, meaning we don't let the entire end-to-end decision process take place without any kind of intervention by the by person or by committee, by people who observe the process. The one benefit I would say about LLM agents versus traditional usage of LLMs is that LLM agents also expose their way of thinking to a degree, meaning we see their what I showed as chain of thought, but there are many other models and architectures that do something very similar. Now you can see that in GPT, it's called deep research or think. There are many features that these companies are coming up with, but they all have in common the idea of exposing how the LLM is making decisions. And so this is one benefit for us, because suddenly we can see what the LLM was thinking in each step of the way. And we can go back and say, look, in step number 5, you actually were biased towards something that we don't think is true. Reroute yourself, branch from that point and start a new process of thinking. So that's, I think, one advantage of LLM agents is that we have that transparency. But that's not to say that the LLM itself is pure. It's still the same LLM that was trained again on Reddit and on Twitter and on other biased data sets. And we have to be very careful not to remove the men in the loop from the decision-making process.
On this topic, and maybe we'll put it in the chat, we did a report a few months ago on generative AI and urban governance. And actually, we interviewed you, Ariel, as an expert of this report. And indeed, I remember one powerful, impactful quote when you said, we need to keep human in the loop, even if it means having less information per second or less data per second. So yeah, that's definitely a very great and important recommendation we definitely have to keep in mind. We have several other questions. One from Mayash, and I hope I will pronounce your name, Batman, asking how can we use AI as urban planning practitioners when recommending implementation? How will this tool be useful?
Yeah, I think this taps into the last question as well, which is the ROI for cities to implement this system. I think we can think about this tool as, and I showed one example of one agent moving through the city, but we can imagine that we have, tens of thousands of these agents when the cost of using them and the speed would be higher, we can imagine tens of thousands of these agents becoming basically one more tool in the toolbox of designers, of urban planners, of architects, of decision makers. And every time there is a conversation about changes to the built environment, whether it's a policy change, extending the hours of opening stores in a street, or otherwise an urban planning change, building a plaza, changing the sidewalks, closing a street or opening it up, changing the FAR and zoning. Whenever we have these interventions, we can basically automatically run these battalions of agents in our streets and see how they react and how they potentially feel in this environment. Now, once again, this is not new. We have been using agent-based simulations before. I think the one advantage we have with these new systems is that we have the opportunity to suddenly talk to them and see how they felt and how they reacted and what they saw and what was the impact, what was most impactful on their experience, something we haven't had the chance to simulate in the past. So in that sense, this is where I see the maximum ROI. And one thing I'll say, maybe I should have mentioned that at the beginning, there is no A/B testing in the built environment. We cannot build and unbuild a building. We can do that with a button on a UI or on an application on our phones, but we cannot do that in the city. And so as soon as we commit ourselves to an investment, we basically have to go through that process and assume that it's going to be beneficial. So we want to create as many mechanisms from the get-go to make sure that we are not putting our money and putting our efforts in the wrong place. And for us, this is one step further towards that goal.
Thanks, Ariel. We have another question. Maybe it will be the last question from Avi. Also, actually, very interesting question. How do you see the combination of bottom-up data gathered from real players, human beings in the city, and the LLM agents?
That's an excellent question. So we actually were thinking about the next step of this work. We did a lot of work analyzing mobility and behavior pattern emerging from what you call, I think, the bottom-up data. In many, many different cities, we gathered location data and analyzed people's behavior, etc. What we want to do in the next step of this work is that we combine these behavioral patterns with the LLM agent. And then, first of all, we can validate whether the LLM agent actually replicates some of these patterns in existing environment, meaning they walk and move and behave similar to how we imagine humans to do so in our cities. But then we introduce the change. We introduce the intervention to the built environment and then say whether the agent actually changed their behavior based on that intervention the way we anticipated or otherwise not. So that would be for us a great way to validate the system. And that will be really the next step of this work.
So here a kind of very strong complementary hybridity between AI agents and still human beings. Okay. Well, thanks a lot, really, Ariel, for sharing all those elements, your wisdom on this topic. It was definitely super interesting. Thanks for all of you also for joining, for your insightful, engaging questions on this topic. The recording of this webinar will be available on our YouTube channel in the coming days. For those of you that will join us in the Urban AI Academy, you will see again Ariel in a few weeks for more time, actually this time, a 1 hour and a half session fully dedicated to his research. You have all information in comments. And in the meantime, take care and bye. Bye, everyone.